Hello everyone and welcome back to the series of Digital Logic Design, and today we will study about binary subtractors. The binary subtractor consists of a circuit which performs the subtraction, and like binary adders, these are also divided into subcategories. Like we have half subtractor, full subtractor, and a binary subtractor for 2 n-bit numbers. Now starting with the half subtractor, a half subtractor is a circuit which accepts 2 input and produces 2 output, and these outputs are difference and the borrow. The truth table for the half subtractor circuit is shown, and the equations for difference is equal to A exclusive or B, and for the borrow it is A prime dot B. Now a full subtractor is a circuit which accepts 3 inputs and produces 2 outputs. The outputs are difference and the borrow. The truth table for the full subtractor is shown, and using the rules of Boolean algebra and finding the equation for difference, it is equal to A exclusive or B exclusive or C, where the equation for borrow in equals C into A exclusive nor B plus A prime dot B. The subtraction of unsigned binary numbers can be done most conveniently by means of complement. Remembering from the previous lectures that the subtraction of A minus B can be done by taking 2's complement of B and then adding it to A, where the 2's complement can be obtained by taking the 1's complement of B and adding 1 to the least significant pair of the bit, where at gate level the 1's complement can be implemented with the help of inverters, and the 1 can be added to the sum through the input carry of a full adder. So the circuit used for subtracting A minus B will consist of full adders with inverters placed between each data input of B and the corresponding input of the full adder. Now the input carry C0 must be equal to 1 when the subtraction is performed. Thus the operation becomes A plus 1's complement of B plus 1, and this will be equal to A plus 2's complement of the B. Now the addition and subtraction operation can be combined to one circuit with one common binary adder by including an exclusive OR gate with each full adder, and this circuit will have capability to perform addition and subtraction, and the logic diagram is shown in the figure for binary adder subtractor. The operation of binary adder and subtractor circuit is controlled by mode input. Like the mode input is connected to the input carry and also to the second input of every exclusive OR gate. Whenever m is equal to 0, the given circuit acts as an adder, and when m equals to 1, the given circuit acts as a subtractor. Now each exclusive OR gate receives m input and 1 input of B. So whenever m is equal to 0, we know the property of exclusive OR gate, which says that B exclusive or 0 will give B. So the full adder receives the value of B, the input carry is 0, and the circuit performs the operation of A plus B. Now whenever m is equal to 1, we have B exclusive or 1 equals B prime, and then input carry is also equal to 1. So all the bits of the B are complemented and 1 is added through the input carry, and then the circuit performs the operation of A plus 2's complement of B. Hence this is a subtraction operation. It is worth to note that the binary numbers in the signed complement system are added and subtracted by the same addition and subtraction rules as are of unsigned numbers. Therefore, computer need only one common hardware circuit to handle both types of arithmetic. The user or the programmer must interpret the result of such additions or subtraction differently depending on whether it is assumed that the numbers are signed or the unsigned. Thanks for watching the video and stay connected for more interesting videos.